During the time of Copernicus, there were major breakthroughs in how we saw ourselves in the universe. Leading up to this era, many believed in something called the geocentric model, which put Earth at the center of the universe. This belief also claimed that everything orbited around the Earth. This came into a major snag when astronomers began to notice that planets would sometimes move backwards through the sky. This seemed to go against the idea that everything orbited the Earth, and so the idea of epicycles was formed to explain this retrograde motion. Another major challenge to the geocentric model was the discovery of Jupiter's moons. This made people begin to question things even further, since everything should be orbiting around the Earth. If some things orbited around other celestial bodies, could it be possible that Earth is orbiting around something as well? This is where the model really began to fall apart. The serious challenge to the model came through Copernicus, who created and developed what is now called the heliocentric model. This places the Sun at the center of the universe and makes the following assumptions. The first is that all bodies orbit the Sun in perfect circles. This is, as you probably know, incorrect for many reasons. We know that instead of perfect circles, objects tend to orbit the Sun on elliptical paths, the intricate parameters of whom we won't get into until Astrophysics 2. For planets, we can essentially assume perfect circles, which makes calculations far easier. Objects that orbit closer to the Sun were also observed to have a higher orbital velocity. Since the background stars didn't seem to move while the Sun and planets kind of wandered through the sky, the sphere of background stars was predicted to be far larger than the distance between the Earth and Sun. The last two assumptions were that the Moon orbits the Earth and that the Earth spins about its axis. This model was a huge game changer for astronomers around the world. It eliminated the need for epicycles and explained why other planets could have moons. While full of mistakes on its own, it provided a huge stepping stone towards a more accurate representation of the universe. Please join me in the next video where I discuss the properties of an ellipse. I hope to see you there.